So let's continue with our linked list playlist. But for that, hey everyone, welcome back to the channel. I hope you guys are doing extremely well. Till now, I have covered singly linked list. Now, over here, we have covered introduction, memory space, how to store it, a conversion from an array to a single linked list, after that, insertion of a node and deletion of nodes. So make sure you have seen the previous lectures because this particular lecture will be about doubly linked list. It will be an extension of single linked list. So make sure your concepts about singly linked list is absolutely crystal clear. So let's have a quick recap. So we did learn about linked list, which had some values, and this was pointing to the next node, and this was pointing to the next node, and assume this was pointing to the next node, and then the last node was pointing to null. Now this was nothing but a singly linked list. Why? Because the direction was just in 1D, right? It was just going forward. You cannot come back from here to here because there is no pointer. Standing at this node, can you say that the previous node is 4? You cannot say it because what you store is, you just store the data and you store the next pointer. That is what we stored. Data basically saying what is the integer value of that node. Next is a pointer that is pointing to the address of the next node. That is what we were storing. So that was for the singly linked list. So let's talk about doubly linked list. As the name states, doubly linked list. So that means you can go in both the directions. Assume you have a node, you are pointing to the next, then you're pointing to the next, then you're pointing to the next. So you cannot go back. So the new change will be, you will also be pointing to back. Yes, you'll also be pointing to back so that you can go from here to here, you can go from here to here, you can go from here to here. At the same time, you can go from here to here, you can go from here to here, you can go from here to here as well. This is what is a doubly linked list. So I hope you have understood what is a doubly linked list. It is very simple, where you can move in both the direction. So you have understood what is a doubly linked list. Now the next step is, how do we represent it in C++ or Java? So let's quickly go back to the representation of singly linked list. How are we representing a single linked list? If you remember, we always had the value. So this value was stored at data, and then we had a next pointer pointing to the next element in the linked list. So we had a next, and we had this constructor which took data, took next, and initialized to the class variables. We can have another constructor where we do not take next, and the next is always pointed to next null pointer. So this was about a singly linked list. How can we store about a doubly linked list? So in a single linked list, we always had the data and we had the next pointer. What extra do we have in a doubly linked list? In a doubly linked list, a node has a data, at the same time it is pointing to the next as well as pointing to the back. So can I say an addition of the back pointer? We need to remember who is the previous. Yes, that is what you need to do. So you can say, maybe I will add a back. Yes, just add a back, and over here probably you can say back 1, and you can say back equal to back 1. Simple as that. That's what you need to do. And in case nothing is given, you can obviously give it as null pointer. So what I did was, I added an extra back pointer to this struct class, whatever you want to call. In Java, obviously the pointer concept will go off. This will be this dot data, this dot next, this dot back. In Java, that's the only change that you have to do. But overall, you got the concept. I simply added the back pointer to my class variable. So I'm storing this in my self-defined object. So now we know how to represent a node in a doubly linked list in C++ and Java. What is the next step? Let's try to convert an array into a doubly linked list. Let's see how we can do it. So what I've done is I've taken this particular array. Whatever problems you have done on singly linked list, what is the one thing that was common? We always had the head, because that is where you start. You need a starting point. Otherwise, you will not be able to know what is the starting point. So we will always have the head of the linked list. Which is the head of the linked list? This particular value 1. This goes into a, maybe I'll use some other color. Yes. This goes into a node. So you put 1 into the node. And if you're putting 1 into the node, it has to have a next pointer. It has to have a back pointer because it is doubly linked list. Let's point the next pointer. Let's have the back pointer. Where will they be pointing to? Initially, we don't have anything. So null pointers. Can I write it something like this? If I write it something like node star, or maybe head, because this was the head of the linked list. Head equal to new node array of 0 because that will always be a head, and null pointer. Why are you passing null pointers in the constructor? In Java it will be null. Why are you passing null pointers? So that this constructor is invoked. You're getting the data, you're getting the next, you're getting the back. Once the constructor has it, it initializes to its class variables. Does it? But do you need to pass null pointers? We also have one more constructor which only is taking the data. In case you don't pass the next and back, it assigns it to null pointer. So what I can do is, instead of passing this, I can straight away say just pass the data and it will automatically assign the next and the back to null pointer. So this is done. We know one thing, that we do not tamper the head. So maybe I'll just store a replica of the head. So I'll name it as previous. Why am I naming it as previous? We'll get to know as we move forward. So I've named a pointer previous, which is storing the head. What is the next thing? I'll have to take this 3, add it here. I'll have to take this 2, add it here. I'll have to take this 4, add it here. So I'll have to add 3, I'll have to add 2, I'll have to add 4. So apart from this first variable, everything from the first index to the last has to be taken. So I'll have to go through each and every element. Obviously I cannot write it line by line. So what I will do is, I will start from for I equal to 1 and I'll go to n minus 1. What is the first thing? I need this variable, right? In a node of a doubly linked list. So I again define a node of doubly linked list and I put that variable. Can you tell me what will be the next of this? I know one thing for sure, the next of this will be null. That's for sure. The next of this will be null. What will be the back? Can I say the back of this will be previous? I can, and that is why I named it as previous. So what I will say is, let's create a temporary node. Temporary new node. And let's pass on array of I. So in this case, array of I will be 3. What is the next? It doesn't point to anyone, so null pointer in case of C++, null in case of Java. What will be the back? It will be previous because that is where it is pointing to. So what happens is, the next points to null and the previous points to, the back points to previous. This is where this constructor will be invoked, where the back will be pointing to it. Once you have done this, what is the next job? I have the temp. I have it ready. I have linked this. But this one, this node, this head, this is still pointing its next to a null. So it's very important that you say, hey previous, your next has to point to temp. So what you have done with this line is, you have pointed this to this instead of the null. Once you have done this, maybe I can take the previous and go forward because the linking has been done. I can straight away move forward. So now what you can do is, you can ask previous to go to the temp. You can either do it in previous equal to temp, or you can say previous equal to previous dot next. It's the same thing. So I've done this and it ends over here. What will be the next job? I will move to 2. The moment I moves to 2, it moves to this one. And then again, this one is created. This time we put the value 2. The next is pointing to null. Yes. And the previous will be pointing to this. The back will be pointing to previous. Once this is done, according to this line, previous is next. So this will go here. After this, you move this one here. And after this, I will be 3. This will move to 4. Once it moves to 4, what will happen? It will again create a 4, point to null. This is pointed to here. This is pointed to here. And then the previous. And after that, this ends and this is done. But since you preserved the head, you can straight away return head stating this is the head of the doubly linked list. And this is how you can convert an array to a doubly linked list. So what I'll do is, I'll move on to the code editor and show you the code. So going back to the code editor, what I will do is, at first I'll create a new file and maybe call it as doubly linked list. Let's create this. The first thing we'll do is, let's copy paste this thing. Done. Ind main perfect return 0. First thing, node star back. Very important. Over here, node star back 1. Over here will be back equal to back 1, and at the same time back equal to null pointer. That's what you will do. So once you have done this, your constructor or your class is ready. So once you've modified your class, let's quickly write down the int main. So what I'll do is I'll take this, that's the best thing, and then copy paste this one. Let's take the array, yes. So you need to convert the array into doubly linked list. So let's try to write it. So I'll be returning a head. So let's try to return a node, and we will be taking this list. Perfect. Maybe take a reference to it. What's the first thing? Let's create a head. How will you create a head? New node. Pass on the array of 0. No need to pass anything else. Right after this, you create a previous which stores head. After this, you move from I equal to 1 till array.size. And then you create node star temp equal to new node. This time array of I. The next will be pointing to null pointer, and the previous will be pointing to previous, basically the back. And then you say previous next, please link it to the new node, and then you say previous, can you move to the temp? Once you have done all of these things, what is the next thing that you can do? You can simply say return of head. Once you've done this, maybe call a print function where you're passing this head so that it can print it. So let's try to print it as well. Void print takes the node star head, and as we know, we can just keep on moving till head is not equal to null, and we can keep on printing cout head of data, yes, and we can move head equal to head next. Once you have done this, maybe let's try to compile it and see if it is running fine or not. Yes, it does. 12587. So this is how you can easily convert an array into a doubly linked list. So let's quickly now check out the Java code as well. So I'll be adding a file, and this time I'll say doubly linked list dot java, and I'll open one new class. I'll write psvm. Post that, I'll just go over here and try to copy the same things. Yes, that's the best thing to do. Let's first copy this. Let's move this. And then let's also try to copy the print one. Where's the print? Yeah, here's the print. Let's try to copy the print one as well. So I'll try to copy the print one as well. And let's also copy the class of node. And after that, we'll make the changes, no worries. Let's now try to make the changes over here. So we need a back. So let's have a back. And over here, let's try to take node back 1. And back, this dot back 1, this is Java, and over here this dot back equal to null. Instead of null pointer, it will be null. So this is done, so I can probably close it, and after that we need to convert it into a doubly linked list. So it will be private static convert array to doubly linked list, and we will be taking the array, right? So let's take the array. Let's go back and try to copy paste this code, because we know it's the exact same thing. And over here, we'll remove the pointers. Yes, I'll remove the pointers. Instead of size, it will be length. And after this, remove the pointers. Say previous dot next. Anything else? Yeah, this will be null. Do I see anything else? Okay, this will be also returning a node. Perfect. I think this is how it will be. And after that, let's try to run it and see if it is running fine. Oh, it does. 12568. This is how the Java code will look like. Super simple. So we're done with the code portion of converting an array into a doubly linked list. What is the next thing? Deletion of a node. So first we'll learn how to delete a head. Then we'll learn how to delete a tail. After that, we'll learn how to delete an node at the kth index. After that, we'll learn how to delete a node that is given to you. So basically, you'll be given a node and you'll be asked, hey, can you just delete this particular node? So let's first understand how do you delete the head of the doubly linked list. So what I'll do is I'll take this particular example and I'll try to delete the head of the linked list. So we need to delete the head of the linked list. Now what are the edge cases? What if the doubly linked list is empty? Imagine you're given a doubly linked list which is empty. Can you delete the head? You cannot. So in that case, whatever is the head given to you, you just return, because you just cannot delete. It's an empty one, right? What's the other thing? What if the doubly linked list is just having one element? In that case, it will always have one element which will have a next pointer pointing to null pointer, you'll have a back pointer pointing to null pointer. In that case, you delete this because that is what you can delete, and then you'll have nothing left. So these two cases are easy to do, right? But what is the toughest case? When the doubly linked list has more than 1 elements. Let's try to think. This is a doubly linked list which has 4 elements. In this, I have to delete this one. And if I have to delete this one, that means the head of the doubly linked list will start from 3. If the head of the doubly linked list starts from 3, it cannot have a back pointing to someone, because we know one thing, the back always points to null. So the first thing, the head has to move here. That's for sure. At the same time, this cannot point to 2. It has to point to null. After this, the previous head had a next pointing to 3. It has to point to null. Once the previous node is segregated, that means it has no connections to anyone, you can delete it. Got it? I'll show you how to do it. I'll be writing the edge cases about empty doubly linked list and a single element doubly linked list when I write the code in code editor. But as of now, what I'll do is I'll try to replicate, or I'll try to write the code for more than 1 elements. I have the head, so maybe I'll just store it as previous. And I'll say previous, can you please store yourself as head? He'll be like, why not? I will. Next, I'll move the head to the next. That's very simple. I will say head equal to head dot next. So the head moves on to the next. What is the next job? I need to make sure that this one points to null, right? Because it's still pointing to 2. Quite simple. I'll say head, can your back point to null, which is null pointer. In C++ it is null pointer, in Java it will be null. Done. So what I've done is I've technically taken this and pointed this to null. That is what I've done, right? What's the next thing? I still have a previous. It is still pointing to this. Yes. I say previous, your next also has to be null. So once I've done this, instead of this, I'm pointing it to null, right? So can I say this is ready? The doubly linked list is ready. In Java, you don't have to do anything, and you can straight away return the head, because the garbage collector will see that this element is empty, and since it cannot be referenced, it will delete it after some time. But in C++, you will have to go ahead and say delete the previous. In C++, you have to do it. So these are the steps that you have to write in order to delete the head of a doubly linked list. So now what I'll do is I'll go back to the code editor and I'll try to delete it. So node star will always return the head of the linked list. Delete the head, and I'll always take the head of the linked list. First thing, if the head is null. If the head is null, or if the head is just the single element, then the next will be null. In both the cases, we just delete it and return null. That's what you can do. In both the cases, you can just delete it and return null or null pointer, whatever you wish to. After this, the first thing. Yes, take a previous and store it as head. After this, you know one thing, head has to move ahead. So let's move ahead. Head's back has to point null pointer. So let's point it. And the previous next has to point to null pointer. Let's point it. After you've done this, you have to delete the previous or free the previous. Once you've done this, you can straight away return the head. Done. Yeah, that's how it looks like. So what I can do is, I can call the head, I can say delete head, and I can pass on the head. Once I've done this, I've written a print statement. I'll call the print, and let's see if it can delete it or not. Yeah, it does. It does delete 12. So I'll copy this code and I'll go back to the Java editor and I'll write private static, copy paste, remove the stars. Yes, here it goes. Here it goes. Perfect. I removed all the stars. What is the next thing? Remove the delete. The next, maybe remove this and make it dots. Quite simple. After this, let's convert all the nulls. Quite simple. Once I've done this, I think we're pretty good. Let's do head equal to, my bad, head equal to delete a head. or rather just the delete head, pass on the head and see if it deletes or not. Yeah, and now let's compile it. It does. So this is how the delete node will work like. So we're done deleting the head of the linked list. What is the next thing? Deleting the tail of the linked list. So let's get back to the linked list, and we need to delete the tail of the linked list. Which is the tail of the linked list? Obviously the last element. So what are the edge cases? Again, what if it is empty? That's one of the edge cases. What if it has a single element? So we have two edge cases, and you know how to handle it. So we need to think about all the other cases. So can I say, if I'm deleting the tail of the linked list, then what do I need to do? This is the tail of the linked list. This is pointing to someone. So instead of pointing to someone, it should point to null. And this is the previous element. Now the next is pointing to this. Instead of pointing to this, it should point to null. So can I say before deletion, this should point to null and this should point to null. If this is happening, this node is basically segregated. It has no connections. And then the Java's garbage collector will free it, or you can delete this, because this is what you need. You need to make sure that the new tail of the linked list is pointing to null, and whatever was the previous element, that has absolutely no connection with the current one. That's what you have to do. How can I do it? First thing I have to do is, I have to reach this tail of the linked list. So what will I always be given? I'll always be given the head of the linked list. So maybe we can start from there. We have the tail of the linked list. Let's try to move. So we'll do head equal to tail of the linked list, or rather tail equal to head of the linked list. My bad. Tail equal to head of the linked list. Let's try to move till the end. Tail goes here. Tail goes here. Tail goes here. How can you move? Make sure you stand. Like the moment you reach the end, you don't move. So can I say, while tails next, very important, while tails next is not null, you keep moving. You keep moving tail to tails next. Can I say this? Why? Because tails next is null. That is when you stop. So this will make sure you stop. You stop at the last element. Once you have stopped at the last element, what do you need to do? You need to make sure you get the previous one. So maybe previous is something that you can get it. Previous will be tail dot back. So if I say tail dot back, this will straight away give me the previous. This will straight away give me the previous. You don't have to think much. So it will give you the previous. What is the next job? Can I say tails back? Since I've stored it, now I can straight away point to null pointer. Make sure you first take the previous and then point the back to null pointer. So I've done it. So what will happen is this will now point to null. Done. What's the next job? This is the previous. This has to point to null. So make sure you do it. Maybe previous dot next can point to null. Done. Once you have done all of these things, you can straight away delete temp in C++. In Java, you don't need to do. In Java, you don't need to do. This is how you can delete a tail of the linked list. Quite simple. So what I'll do is I'll again go back to the code editor and I'll try to write node star delete tail. And I'll take the head. This time I'll write the same thing. Give it a single element. Do whatever you wish to do. Let's say the tail equal to head, while tails next is not equal to null. We do tail equal to tail next. Once you have done this, you say node star previous tail, or the new tail, whatever you wish to call it. It's a new tail technically, equal to tail back. Now this is where doubly LinkedList is useful. You don't have to store the previous. You can straight away get the previous by doing a back. After this, the new tails next will be pointing to null pointer. After this, you say the previous tails back will also be pointing to null pointer. Let's do it. Once you have done this, you can delete this particular tail and you can return the head of the linked list. You need to return the head of the linked list. Yeah, you can straight away return the head of the linked list. And instead of saying delete head, let's do a delete tail and let's see if it runs. Technically should. Yeah, it runs. Let's copy paste the same thing. Go back here and say private static. Let's paste it. Let's remove it. Let's remove the stars. Let's remove all of the stars. Done. Once you've done this, the next thing, let's convert it into null. And let's remove the delete part. After this, let's convert this one, this one. You see, same code. Nothing is different. Once you've written all of these things, you just go ahead and run this and see if it is running fine. Oh, my bad. I'm still deleting the head. Let's delete the tail. And now let's run it. Yeah, it deletes it. Super easy. Let's quickly get back into the iPad, and I can say that I solved the tail one as well. The next thing, how do you delete the kth element of that doubly linked list? So I'll have to delete the kth element of the doubly linked list. So let's first analyze the edge cases. First edge case is very simple. If the linked list is empty, you don't do anything. And it's given that k will be between 1 to the length of the linked list. In this case, the length of the linked list is 4. So k will always be between 1 to 4. It cannot exceed it because that element will not be there. So let's first analyze all the cases. What if k is 1? In that case, it will have a next element, but it will not have any previous element. That is for sure. What if k is 2? It will have next as well as previous for sure. What if k is 3? It will have next as well as previous. Only for k equal to n, which is 4, the length of the linked list, it will not have a next element. It will not have a next element, but it will have a back element. So the edge cases that I have to think is for k equal to 1 when the previous is not there, and for k equal to n when the next is not there. There might be one more edge case. What if the doubly linked list is having a single element? In that case, it will neither have the next, it will neither have the back. So we need to think about all the cases. But the first thing we will try to do is come to the node, which is the kth node. Let's first try to come to the kth node. So whatever k is given doesn't matter. The first attempt should be coming to that node. So let's try to do it. I'll be like, initially count is 0. Initially the count is 0. So let's store a variable count equal to 0. So what I can do is I can say count equal to 0 while, and maybe I can store something like temporary equal to head so that we don't tamper the head. And I say, hey, can you just keep on moving? He'll be like, why not? I can keep on moving. So while temp is not null, basically till the linked list is not traversed entirely. So let's try to move. And what I will do is I'll keep on doing counter plus plus every time it moves. And at the same time, I will say if counter is equal to k, please break. So what happens is counter is 0. It comes inside counter plus plus. So counter is 1. Is that equivalent to k? If it is, then break. Then it is, then break. Then the temp will always be standing here in this case. Or else if it is not, you ask the temp to move to the next. So what happens is you keep on counting and you keep on moving. So if this is not, then what happens is counter is 1 and the temp moves to here, and then counter becomes 2. Then you check if this 2 is equivalent to this k, then you break. So whenever you break, you will always have your temporary pointing to that node. So what I've done is I've made sure my temporary is pointing to one of the nodes, which is, or rather the only node, which is the kth element. That is something which I've made sure. So with this, I'm standing, or my temporary is definitely standing at the kth node. Now I will have to think of the edge cases. Obviously one of the edge cases is, so let's maybe do one thing. Let's keep the previous element, a previous node equal to temporary dot back. That's the previous. And let's keep the front element, or the next element rather. Maybe let's call it the front. Temporary dot next. So what I have is temporary standing at the kth node. I have a previous element at the previous node. I have the front standing at the next element. So everyone is standing at 1 nodes, correct? Now what is the first edge case? What if we don't have a previous and front? That might be a possibility when we have a single node doubly linked list. In that case, count will be 1 and you stop. Temporary is pointing here, it doesn't have an x, it doesn't have a back, right? That might be a case. So we will try to write it for that. What if my previous is null and my front is also null? That's one of the edge cases for sure. In that case, you simply delete that node and return null. You simply delete that node, whatever is your node, which is temp, and you return. That's the simplest thing you can do. What is the other one? The other one can be if just the previous is null. Just the previous is null. So if this if is not satisfied, you come to else if. And you say, what if the previous is null? Then where are you standing? You are definitely standing at the head. You're definitely standing at the head. In that case, what do you need to do? You need to delete this. You need to delete this. So we just call delete head. We just call delete head and it will do my job. Can I say this means deleting the head of the linked list? I can. So what I will do is I'll simply call delete head function that I wrote. Delete head with the head. And then I will simply return something or whatever is needed, I'll return. Done. What's the next job? What if I'm standing at a case where my next or the front is null? What if that's the case? The front is null. What will I do in that case? If my front is null, what does that mean? I'm standing at the last node, my temporary is at the last node. That is why my front is null and my previous is not null. That's the only case. I'll delete the tail. I'll delete the tail. Let's call delete the tail. So I'll go ahead and call delete tail of this linked list. Quite simple. Of this linked list, and then I'll return. And if neither of this is satisfied, it means you're standing somewhere in between. It means you're standing somewhere in between, and we need to take care of that case. So we've written all the code. We just need to think of the other cases. Let's see. So we have some linked list. It has a previous now. It has a temporary where you're standing basically the kth node, and then it has a front. How are they pointing? It is definitely pointing to some node. The back is pointing to some node. Over here, the next is pointing here. The previous is pointing here. The next is pointing here. The next is previous is pointing here. That is something we know for sure. How will the pointers look like after I have taken off this? After I've taken off this, can I say the previous next should always point to this? Can I say this? The previous next should always point to this. I can. I definitely can. Okay. And can I say the front's back should point to this? So what I can say is previous next should point to front. So what happens is this straight away goes and points to this. Yes. And if I erase, this will no more be there. But this will be there. This will be there. Next, can I say front back will be pointing to previous? So what will happen is this will straight away come and point to this. Hence, this will no more be pointing to here. Done. So what I've done is this linked list while going is now going like this. This linked list while coming back is now going like this. We still have a temp, but it's not in that particular doubly linked list. But it is still there and it has still pointing here and it is still pointing here. I need to get rid of these pointers. So I will say temporary dot next. You just cannot point to anyone. Null. Temporary dot back null. And once you have done this, Java's garbage collector will delete it, or else you call free temp and then you can return. This is what you can do. You don't need to return the head, because if you delete the pointers, the head will automatically not find it. The head will automatically not find it. Done. This is how you delete the kth element. Understood? Quick recap. If I do a quick recap, we need to find the kth element. So the first thing I'll do is I'll try to take the temporary and stand at that kth element. That is what I'll do. And this is the line of code that will do it. This will make sure that the temporary is standing at the kth node. Once it is standing, I can easily get the previous and I can easily get the front. What if both are null? It means it is a single element doubly linked list. It is a single element doubly linked list. That is what it means. Got it? What if the previous is null? It means temporary is the head of the linked list. So you delete the head. What if the front is null? It means you are standing at the last. You delete the tail. What if both of them are not? You simply go ahead and do these link changes, and that will make sure that the deletions have been done on the pointers. So what I'll do is, let's try to write down the code. So we'll be returning a node. Why? What if the kth element is the first element? Then the head might change, right? The head might change, so we will have to write it. So remove kth element. So what will we take? We'll take the head and we will take the kth element. And we know one thing for sure. If the head is null, we just straight away return null. After this, we take a count equal to 0. We take a node star. We need to find the kth node. So we can take it as head. And we can say while k node is not equal to null, we do counter plus plus. If counter equal to k, we break and we do k node equal to k node next. So we keep on moving till we do not reach. And this is under the assumption that k will be between 1 and the length of the linked list. Once you have reached, can I say, I'm standing at the kth node. So I need the previous node, which is k node back, and the front node will be k node next. Agreed. After this, can I say if previous is equal to null and the front is also null, it means it has a single element. If it has a single element, I just need to delete it. And if I have to delete a single, I can straight away return a null, because that will be my new, because if you delete everything, it will not have anything, right? Else if, what if the previous is not there? Okay, if the previous is not there, in that case what will happen is, it's a head. I need to delete the head. So I'll return whatever delete head will give me, because it will also give me a new head. So I'll go ahead and delete this head. Else if the front is null, that means I've been asked to delete the tail of this. So I say return delete tail and I pass this on. Perfect. Once everything is done, if these two conditions are not met, in that case I simply return head. But before this, we need to change some pointers. How will I change the pointer? I have the previous, right? I have the previous. So as the previous, your next should actually be front. I just remove it. And front, your back should be previous, because this middle kth node is gone. Like perfect. So k node, your next should be null. He's like correct. K node, your back should be null. He's like you're correct. And you should not be there. Why are you here? He's like, yeah, I should not be there. Done. So can I say, I can probably replace the head, because what if it's a new head? Because if you delete the head, it will be a new head. And as I delete kth element, so okay, remove kth, not delete. It's named as remove kth element. Remove kth element, and I pass on the head, and I say let's remove the first element. Let's see if it is working or not. Hopefully it works with 1. Yes, removes. Let's see if I put 2 and compile it. Works. Let's see if I put 3 and compile. Works. Nice. Let's see if with 4 it works or not. It does work. I need to write the Java code. You know, right? How to write the Java code. Everyone knows now. Let's remove the stars, remove the nulls, null pointers, and yeah, these things. And it will be the exact same Java code. So I'll not be writing the Java code. So I'll go back to my iPad and I can say that removing the kth element is also done. What is the next? Removing a given node. So the question is stating, you'll be given a node and you'll have to delete it from the doubly linked list. Now over here, one thing is clearly stated. The node that is given cannot be head. It will never be head. This is what it states. Why? I'll explain you while I code it. But as of now, just keep this constraint in mind that whatever node is given to you, that is never the head of the doubly linked list. Let's try to think. What if this node is given? Then you simply do this, right? What if this node is given? Then you simply do this, right? What if this node is given? Then you simply point it to null, right? That's what you do. How can I do it? Let's try to think. Can I say I've been given a node temporary? So if I've been given a node temporary, it will have a node at the back of it, which I can call it as previous. It will also have a node on the front of it, which I'll call as front. So I can easily get the previous by stating temporary dot back, and I'll also get the front by stating temporary dot next, right? So what I can straight away do is previous dot next will be pointing to front, front dot back will be pointing to previous, and then I can cut off this link, and I can cut off this link, and then I can delete temp. Quite simple. Only one edge case that I have to think about. What if I don't have a front? Because when I'm standing here, when my temporary is standing here, the front is null. It cannot have a pointer. So I'll have to take care of it. So I'll show you how to take care of it. So let's quickly get back into the code editor and try to delete it. Void function, node, takes a node, temporary. What do we need? We need the previous. So maybe node star previous will be temp dot back. Node star front will be temp dot next. Done. What if the front is null? Which is this case. Let's analyze. What if your temporary is given here? Then the front will be null and you'll just have a previous. In this case, this will straight away be pointing to null pointer. That's it. And this is a link that you have to break. So you'll say, hey, previous, your next should be pointing to a null pointer. He'll be like, yeah, you're correct. And you can just free. What will you be freeing? You'll be freeing the temp. That's it. Make sure the temp's back is also pointing to null pointer. Done. And then you can straight away say return because it is a void function. No need to execute the next lines. But what if it does have a previous and a front? Break the, take this link and join this, take this link and join this. So previous dot next will be front, front dot back will be previous. Done. After this, you have a temporary who's next, who's back. Both of them will be pointing to null pointer. And after that, you can free temp or delete temp. In Java, you don't have to do it. That's it. Since it is a void function, you don't delete. Done it. Let's take it off and say delete node. I cannot delete head. Why? I'll explain you. Imagine I say head dot next is what you have to delete. So what I'm passing is delete 5. Head dot next means the pointer pointing to the node having 5. Let's see if it can delete it or not. It does. If I say next, it'll be deleting 8. If I say next, it'll be deleting 7, right? Because that is next. It does. I cannot say head. Why? Because if I say head, then this particular head will be moved. You'll have to take the new head to 5. You have to take the new head to 5. Got it? So you'll have to write more and more conditions. That is why this question will never be asking you to delete the head of the linked list, any other node. Got this? So if I can come back to the iPad, I can say that this one is done. And with this, we'll be completing deletion of node. What is the next one? Learning about insertion of nodes. So again, 4 varieties. Insertion before the head. Yes, very important. We'll be doing before. I'm assuming you can do after as well, but I'll be teaching you before because that is slightly tougher. After is very easy, so you can do it yourself. Before the head, before the tail, before the kth node, and before a given node. So these 4 are the ones that I'll be doing, but make sure that these all 4 questions will be before the node. You can try out at your home after the node. That's very, very simple. So what is the question stating? You'll be given the head of the doubly linked list and you'll be given a value, right? You'll have to make this node with a value 10, and this will be the new head of the doubly linked list. That means the next of it will be pointing to this, and the back of this will be pointing to this. This is what you have to do. So what is the first step? Can I say the first step is for sure creating this node with a value 10 whose back is pointing to null and whose next is pointing to the previous head? Can I say this? I can. So I'll go ahead and write node star new head equal to new node with the value comma what? Comma its next should be pointing to the head and the previous should be pointing, or rather the back should be pointing to null pointer. So with this line what I've done is I basically created this new head whose next is pointing to this head, right? And this null is from this. Done. I need to make sure that this back which is pointing to null should be pointing to this. So can I say the back? So can I say the head's back should be pointing to new head? I can. So what will this do? This will make sure that this is pointing to this. Once this is done, you can straight away return the new head. That will make sure that you have the new head, right? So let's get back to the code editor and try to write it. So node star, because we'll have to insert before head. So let's insert before head. So I'll be taking the head and I'll be taking the value. And what I will be doing is, first thing is node star new head, right? New node, and I need to put this value. The next will be head and the previous will be, the back will be null pointer. Previous is head, like whatever was the previous head, that back should be pointing to new head. Done. Once this is done, I can return the new head. So what I've done is I've written this function, and now let's see. Yeah, it's inserted before this, the 10 is inserted. So this is how you insert before the head of the linked list. So I can say that this one is done. What is the next thing? Insertion before the tail of the linked list. So let's analyze this tail of the linked list. So I have to put a node over here. Assume it's given a value 10. I'll have to put a node with value 10, whose next should be pointing here, whose back should be pointing here. So basically what I have to create is, I have to create a new node with a value 10, and the next of this should be pointing to this, and the back of this should be pointing to this. But I'll also have to make sure that these pointers are erased, and now the next is pointing to this and the back is pointing to this. I'll also have to make sure so that it kind of comes in between that linked list, right? How can I do it is what I need to think. Let's go back to the previous. First, create this list. So first thing that I have to do is I'll have to take a tail. Maybe let's take a tail. Let's try to take it to the last of the linked list. And that's very simple. You say tail equal to a head, and you say while tail is not at the end, or tail dot next is not the null. Tail dot next is not null, right? And you keep on moving the tail. So what will happen is the tail will go from here to here, then it will go from here to here, then it will go from here to here. So you're standing right at the tail of the linked list. So you have the tail of the linked list. Now you have to think of this. So let's get the previous of tail. So the previous of tail will be tail dot back. So I'll also have the previous. So I somehow have the previous. Now you have the value that you have to put. Imagine it's 10. First thing, let's try to put this value. Let's create a node with 10. How can you create a node with 10? You can say the new node will be new of node and 10. Where will the next point to? The tail. Where will the previous point to? The back point to? The previous. So if you do this, what happens is there's a node created whose next is pointing here, whose previous is pointing here. Done. First thing done. What's the next change that you have to do? You'll have to take the previous is next and point it to this. So let's do it. The previous is next should point to the new node. Done. What's the next thing? The tails back should be pointing to this new node. So the tails back should be pointing to the new node. Again, very simple. Done and dusted. So this logic works for all the doubly linked list which has more than one element. What if the doubly linked list has just one element? Then it is the tail of the linked list, and the question is asking to insert a node before the tail. Technically, it is also the head of the linked list. Technically, it is also the head of the linked list, isn't it? Because if it's a doubly linked list with one node, that is the head, that is the tail. So you can just call insert before head, the one that we did before, and it will give you a new head. That will do it, right? So let's quickly get back into the code editor. And try to insert before the tail. So I'll write node star insert before tail, and I'll take node star head and value. What is the edge case? If this is the head, like it's only with one element, it's guaranteed that it will have more than one element, don't worry. So if head dot next is equal to null, it means it's a single element. And you say insert before head and you pass on this head and the value, it will do it, and it will give you a new head that you can straight away return. In case it is not, then you say node star tail equal to head and you keep on moving till the next is not equal to null. So you say tail equal to tail dot next, keep on moving. What's the next step? Tail has reached, right? So you need the previous tail. So tail dot back. Perfect. What's the next thing? Node star, this new node will be new node with this value. The next will be tail. The previous will be previous. Done. Now the previous is next. Can easily point to this new node. And the tails back can point to this new node. And then you can straight away return the head of the linked list. So insert before tail, and let's see if it can do the job or not. Oh, it does. So this is how you can easily insert before the tail of the linked list. So we are done with inserting before the tail of the linked list. Now the next thing is inserting before the kth node of the linked list. Again, it's the same question. So the question is stating you'll have to insert before the kth element. Imagine you're given k equal to 3 and a value equal to 10. So which is the third element? This one. So you will have to insert before this one, which means somewhere over here, Now this is what you have to do. How can I analyze this? We have done two questions. Inserting before head, inserting before tail. These things we have done. So can I say if k is 1, it points to head and it boils down to inserting before head. If k is n, in this case n is the length of the linked list and k will always be between 1 and the length of the linked list. If k is n, or in this case k is 4, that means it's the tail of the linked list. And if it is the tail of the linked list, the question boils down to inserting before tail. So we can easily solve it. We have to only think about two cases, which is what if my kth node is not the head or not the tail. So the first thing that I'll have to do is I'll have to go to that node, right? So maybe I will take a temporary. So I can initially say temporary to be head and count to be 0. So initially imagine count is 0. So while temporary is not equal to null, let's keep on moving. Count equal to count plus 1. And I can say if at any moment count is equal to k, we can break. Again, we have done this. I'll not be explaining. We've already done this in deletion. And we do temporary equal to temporary dot next. So what is happening is we start with the head. And we keep on moving, right? So imagine k is 3. What will happen is we will end up being here. When the count is 3. So I'll quickly erase this previous thing. Yeah, we will end up being here when the count is 3. What after this? When I'm here, it's a simple question. You take previous, so this will be your previous. You have previous equal to temp dot back. Once you have your previous, once you have your temp, how tough is it to insert a value? It is not. The only complicated case over here is when k is 1. If k is 1, then the head of the linked list will change. So you have to call insert before head. Otherwise, the head never changes. You just put it, you just change link, you put it, you change links. Quite similar to what we have been doing. So I'll not explain how to do it. So the overall algorithm focuses on reaching the kth node, and then it's super simple. So what I'll do is I'll quickly go back to the code editor and I'll say node star insert before kth element. And I'll say node star head val, and maybe we'll say if k, rather k and val, yes. If k is equal to 1, it means you have been asked to return before head. And I've been asked head is this and this is the value. Perfect. You get the new head and you return. What if you're not asked for the head? In that case, you take a temporary equal to head, and then you take a counter equal to 0. You move this temp till not null. You say counter plus plus. If counter is equal to k, you break temp equal to temp dot next. Perfect. So the next thing we'll do is we will take node previous equal to temp dot back, and then we have to create a new node. So node star new node equal to new node, and this node will have this value. The next will be pointing to the temp and the previous will be pointing to the previous. After this, the previous is next will be pointing to the new node, and the temps back will be pointing to this new node. Once you have done this, you can return the head. So I'll quickly call insert before kth element, pass on 1, and let's see if it works or not. Terminate task, and let's see if it works or not. Let's quickly compile and see. Yeah, it is inserting. Then let's change it to 2 and see if it is inserting before 2. Yes. Let's change it to 3. It does. Let's change it to 4. My bad. Okay. It does. So insert before kth element is also done. What is the next question? So coming back to the iPad, I can say that this one is done. Which one is the next question? Inserting before a given node. And it is guaranteed that this given node is never equal to head. Why? Because if you insert before a head, the head will change. And the question doesn't want you to change the head. It is just wanting you to insert something before the head. So let's quickly get back into the code editor and try to write it. Again, it will be a void because there will be a no change of head. Insert before a given node. So let's take the given node and assume this is the given node and they're asking you to insert this value val. I need the previous node. So let's take the previous node equal to node back. After this, I'll take new node equal to new node. I need to have this val. The next will be pointing to node and the previous will be, the back will be pointing to previous. The previous is next, pretty similar to what we have been doing all the day. And the nodes back will be pointing to this new node. Over here also new node. Done. This will make sure it inserts before. So I can just omit this line. I can say insert before. Let's assume I say head dot next is the node. Basically, I want to insert before 5 a value of 100. Let's see if it can do it or not. Let's try it. It can. What if I give next? I think it should be able to insert before 8 as well. It does. So I'll be giving. I don't want to change the head. That's why it is just an insertion method. It's not changing the head. So that is it for this one as well. With this, we complete insertion of node, all the 4 patterns. Again, we have solved, I think, 9 or 10 problems in this particular lecture. And I hope you have understood doubly linked list in depth. And where is doubly linked list used? In your browser. Whenever you keep forwarding from one page to another page to another page to another page, and then you come back. Again, you can go front. So doubly linked list is used. So before wrapping up this lecture, what I'll do is I'll quickly jump into Code Studio's code editor so that you understand how questions will come up in an online assessment, because in an online assessment, you will not get something like VS Code. You will just get this function and you will have to complete it. Got it? So we will be solving 3 problems on this particular editor. Like the first one, construct it from a list. I think we wrote it. Let's quickly check it out. Yeah, we wrote it over here. So I'll quickly take this and try to copy paste it. And then I'll quickly submit this and see if it is running fine. Should be running fine. See, over here, this int main is something which is technically always hidden. It's always hidden behind the scenes, right? You just need to write this and then they run the code. So let's quickly try out the next question. It is stating insertion at the end of the doubly linked list. We did insertion before the tail. Now over here it is asking you to kind of replace the tail. You will have a new tail. So can I say if the head of the linked list is empty, in that case the linked list is empty and it's an entirely new doubly linked list with this value k. Straight away return this. Or else you reach the tail. So let's quickly try to reach the tail. So in order to reach the tail, I know that I'll go tell tail dot next not equal to null, because at the tail the next will be null, right? So tail equal to tail dot next. Perfect. I'm standing at the tail now. I need to create this new node. So let's create this new node. And I can say new node with the value k, the next of this new node, because it is the tail, it will be null pointer. But the previous will be pointing to the current tail. What is left? We have created a new node, made sure the back pointer is pointing to the current tail. But the current tails next should be pointing to this new node, otherwise it will not work. Once this is done, you return the head. That is why you should never alter the head. Let's quickly try to run this off and see if it is running fine. It should. Let's quickly try to submit this and see if it is being submitted or not. It's very important to practice in different environments, because over here you see node.next and node.previous. We used something as back, right? They're using something as previous. So you need to be careful. Make sure you always check this out. What is the class definition in your online assessment? That is very, very important. Let's quickly check out the last problem for the day, which is deletion of the last node of a doubly linked list. Can I say this is similar to deletion of tail? I think I can. So I'll just copy paste this. I'll delete it and try to run it and see if it is running fine. Okay, there is, as I said, over here we have previous. So we cannot use back, so we will have to use previous. Okay, I've used previous. Now let's see if it is working fine. It should. Let's quickly submit this. So it's very important that you get used to this online assessment. So what I'll do is I'll put the question links for all the 10 problems. I think we did 10 or 11 problems in this particular lecture. So what I'll do is I'll put all the problem links in the description. Also at the same time, you can go to the step 6 of the Strivers A to Z DSA course in order to figure out all the problem links and the article links. There are notes in C++, Java, Python and JavaScript. So make sure you check out all the code links and read the articles, because the articles are of premium quality. In case you're still watching, please do consider giving us a like, and if you're new to our channel, do consider subscribing to us as well, because 50% of the users who watch our video do not subscribe. So please, in case you haven't subscribed, please do subscribe. And if you haven't followed me on Instagram, Twitter and LinkedIn, all the profile links will be in the description. With this, I will be wrapping up this video. Let's meet in some other video. Till then, bye bye, take care.
Whenever your heart is broken.